So, shear and moment diagram na. So, yan nira ang pagkuhan sa shortcut using area method. If you have, say for example, this type of beam. So, gusto man mo kaning focus. So, we're given with a beam whose total span is 8 feet because from A to B it's 4 feet. And then from B to C it's 4 feet. And the load here is just a simple uniform load, which is 400 pound per foot. So for every foot, there is a 400 pound load. Alright? So the first step is just calculate the support reactions if it is not given. So to do that, just have to draw the free body diagram. Like that. And then convert this distributed load into a point load. So with that, since it is 400 pound per foot and it is distributed to 4 feet, so 400 times 4. And that is located at the center of this shape. So 400 times 4 is its magnitude. And then here we have, since this is a pin, we have two reactions ng horizontal and vertical. But then our concern is only just the vertical, because in beam, calculating the shear and moment diagram or drawing it, ang ato ang concern is the transverse loads or the loads vertical or perpendicular to the beam and not those horizontal. Because if the load is horizontal, that would be axial to the beam. Anyways, here's RA. So the reaction at A. And then here's RC. So that's the reaction at point C here. Here. And then what? The dimensions. This is 4 feet here. And then 4 feet here. Alright? And if we sum up all the forces in the vertical direction, that should be equal to 0 so that it will not move. So 400 times 4, that would be RA plus RC, or all the force that goes up must be equal to all the forces that goes down. And since the only force that goes down here is the 404, so that's just what RA plus RC will be equal to. And then with that, we again sum the moments. It could be at A or at C, anywhere along the beam, and I choose A. And so with that, again, so that it will not move, all the moment that goes counterclockwise should be equal to all the moments that goes counter. So if this is the point where we take the moment, RC is 8 feet away. So it should be 8 RC. That's equal to, the only force that counters this RC is this. And here, since it is the centroid, should be 2. Since this is 4 feet and then this is 2 feet. So the total moment arm is 4 plus 2, which is 6. So 400 times 4. That's 8 RC is equal to 400 times 4 R load times the moment arm, which is 4 plus 2. And that's 6. And with that, we get the value of RC. And then, if we substitute this, there is a RC, we'll get RA eventually. So the value of RC is 1,200. And then for RA, it's just 400 times 4 minus RC, which is 1,200. And that would be equal to 400. So as you can see, 1,200 plus 400 is equal to 400 times 4, which is also 1,600. So now we're done with the support reactions. So isulat na nato dire. This is RA 400 and then RC, which is 1,200. Then let's draw the lines. So here mo ni siya ang V diagram. That's in pound. So this is in pound. So to draw the shear diagram, if we have here 400, going upwards, we just go upwards and write 400. That if we're going from left to right. If gikan to sa right paingos left and we have this 1,200 here, that would be negative here. Alright? And now we're going to the B. Paingon na po tas B. Since this walay ko andre from A to B, there's no other load here. The drawing would be just straight line. So it's constant from A to B. And now from B to C, since that's distributed load, so from 400, just write 400. You just have to subtract the area of this W loading or the distributed load, and that would be 400 times 4. And if we do that, 400 minus the area, which is 400 times 4, we're gonna get negative 1200. And that should match with our reaction at C. So we go down to negative 1200. And with that, since this is the order of the lines, if the line is here on the loading, the next would be a line, and then a second degree, and then a third degree. This is third degree, second degree, and first degree. This is constant. And since we have here constant, so the next would be this linear, right? So from here, from 400, we go down to negative 1200, and this is now our shear diagram. So again, we rise up from 400, and then it's constant here until up to B, and then we go down as this load pushes our paan downwards. So from 400 minus this area, 400 times 4, we go down negative 1200, and then this reaction pushes upwards, so that's going to 0. Then for the moment diagram, since there is no concentrated moment here at A, we start from 0. If naani siya dire, paana concentrated moment, that would be positive. If paana, negative. That's external loads. That's for external moments. And since wala man ta dire, so ato ibutang ra is M is 0 at A. So at A. And then to get to B, we just have to get the area of this. Since na siya positive, the area is positive, and otherwise if na siya there, this is negative. So kana 400 times 4, so that's the area of this. This is just a rectangle, so 400 times 4. So with that, we start from 0, and then we add. So 400, or from 0 plus 400 times 4, and that would be equal to 1600. So from 0, we go to 1600. And the order of the line, since this is constant, next would be like that. That's first degree. Then the area of this. So how do we get the base, or this length here? So we just use the similar triangle. So this triangle is similar to this triangle. So if we let this as x right here, and then our height is this 400, so x over 400, that should be equal to this one. This height here is equal to here. So this is negative 1200. So ignore the sign first, just the length from here. 400, this is 400, and then plus 1200. So that's 1600 all over this length from here to here. So the triangle is this is to this, and then this is to this. So this would be 4 feet. So 1600 over 4. So if we simplify that, 1600 divided by 4 is just what? 400. Am I right? Or am I wrong? 1600 is to 4, and then x. X is no. It should be 4 over 1600, because this is for the base to base, and then height to height. Alright. So 400 times 4 is just 1600, and thus x is 1. So at x equals 1, the shear should be maximum. So the area of this triangle here, we draw another line here, because kay sa kuan mong god sa shear, if mo dapat siya sa 0, maximum na siya sa moment. So the area of this is just 1/2 base times height. So 400 times x divided by 2, and we know that x is just 2. So the area should be 200, and then add it to 1,600. So 1,600 plus this area, which is 200, we go up to 1,800. Alright. Dayon, the area of this small. If this is 1 here, this should be 3 here because the total length is 4. So 1 and 3. So the area of this should be negative. So 3 times 1,200 divided by 2. So how much is that? That's 3,600 divided by 2. That's 1,800. So from 1,800, we subtract this area because this is negative. So 1,800 minus 1,800, that would lead us to 0. Alright. So now the shape is, the line is from here, kaan man siya ng first degree. So the second should be, or here should be second degree. And ang iyang shape is just timan irani nga this is PD, NI, ND, and PI. Please do not neglect dumb people instead. So here we have a positive area, and then from left to right it's decreasing. So here positive decreasing. So we follow the shape positive decreasing. So here mana siya kurma. It goes positive decreasing. Alright. Then here negative from left to right is increasing. So negative increasing here. Ana ning shape ani. So that's it. So yan nila basically how to draw the shear and moment diagram through the shortcut method or the area method.